Hi, grade 8s. Well, for those of you who looked this morning, you probably noticed that nothing was working on my video, and I just took for granted that everything went just fine. So, lesson learned on my part, I gotta check all the settings to make sure it's working properly. Alright, so let's try this again. So we're going to be solving some one-step equations where we're going to be modeling and solving what's going on. So I'm going to have you go through some of the modeling here using something we call algebra tiles, and we're going to be using these a lot more in grade 9. So I do want you to try and go through and practice this. Now I know for a lot of these questions you're going to be thinking, I can get the answer in my head, there's no need for me to do this, this is easy. And yes, I know you guys can do it in your head, you're smart. But I still want you to go through and practice the way I'm showing you, especially the algebra, because as we move into grade 9, things are going to get a lot more difficult, and the answer won't always be obvious when we look at it. So I want you to practice the right steps now while it's easier. Okay? So for modeling these things, I'm going to have to come up with something here. We use these things called algebra tiles. So I've got these rectangles here. And both of the rectangles are going to be the same size and shape, but one is going to be colored in green and the other is left blank. The one that's colored in green represents a positive x, and if it's not colored in, same size and shape, that's a negative x. Okay, we call it an x because we say the width is 1 and the length is an undetermined value, so we don't know how big the length is. So the area of that is going to be 1 times x, and whatever x is, it's just going to have that area. So if x was, let's say, 7, 1 times 7 would give us a value of 7. So we have that fixed width of 1 and an undetermined length of x. So that's where we get that x tile from. We're also going to use these little tiles for our 1s. And if those 1s are colored in, that gives us a positive 1. And again, if it's not colored in, we get a negative 1. Okay? And again, that has a fixed width of 1, but then the length is also the same distance as the width, so it's 1 by 1, and that gives us an area for that tile of 1. Okay? So using those, I'm going to go through and model this. So if I've got 4x, that would mean I would need 4 of those rectangles, right? In total, there should be 4 of them. Now they were positive, so I'm going to color in those x tiles, and I'm just using green because that's what you're also going to see in your textbook. Okay, so I've got my 4x tiles on the left-hand side of the equal sign. So I'm going to break my model into 2 equal sides. I've got my left side and my right side. And on the right side, I have 12 ones that are all negative. Okay. Now, I've kind of cheated a little bit as I've been drawing this. I'm doing it purposefully where I had my 4 x's laid out into 4 nice rows, and then I organized my 12 negative 1s equally into those 4 rows. And this is basically what we're doing when we're modeling this one, is I'm saying, well, I have 4 x's, and if I organize them into rows, every row contains an x as well as 3 negative 1s. So I have 4 equal rows. All right? So since I have those 4 equal rows, I'm saying that every row contains an x as well as 3 negative 1s. And that x, of course, is colored in. And so that's all we have to do in order to solve this one, is now we say x is equal to negative 3. Okay? So our original statement said 4 times some number is negative 12. Well, that some number, that missing number, is negative 3. Okay? All right, let's look at another one here. So I got r divided by negative 2 is equal to negative 8. Now one thing to notice, r over negative 2 is the same thing as negative r over positive 2. The negative can live either in the numerator or in the denominator. It doesn't really matter. For the modeling, I'm going to move it up to the numerator, okay? But often I will keep it in the denominator, and I'll show you why in a minute, because I can actually get rid of that negative in one step when I'm doing this algebraically. So r over 2. This one looks a little bit different, and what we're going to see is I'm going to let this whole circle represent an r, okay? But I'm going to split the circle into 2 equal portions, and I'm going to focus just on one of those portions here, right? Because I've taken r and I've cut it in half. half. So this represents a negative r over 2. Okay? So I have half of my r is colored in, and on the other side I need 8 negatives. So I've got 1, 2, 3, 4, 5, 6, 7, and 8. So what I'm saying now is when 1/2 of that circle is colored in, I have 8 negatives on the other side. And so if I was to do the same thing and I color in my 1/2 here, I need to have my 8 negatives. I'm just going to try and cheat here a little bit so that you don't have to hear me smacking the smartboard with the pen. So I've got my 8 negatives there when I color in that half. So every half is 8 negatives. Well, if I color in the other half, that other half must be worth the same amount. So I have to add 8 more negatives. So in total, I now have 16 negatives, right? So if you look, my first half represented one grouping of these guys here. That's the first grouping, was that half. The second half gave me the second grouping right here. So each half had -8 associated with it. So as I colored in 1/2, I added 8 negatives. And then I color in the second half, I added 8 more negatives. Okay? Now, this is a problem because if you look my circle, when it's all filled in, the whole thing is not r, it's -r. So I have something that says -r is equal to -16. And that's not really what I'm looking for. I want to know what the letter r equals. And right now I don't know what the letter r equals. So I have to change this. I don't want -r. I want it as positive r. Okay? I care about positive r. So if I'm looking for positive r, what did I do? Well, I just found the opposite. The opposite of -r is positive r. I'm going to do the same thing to the 16. The opposite of -16 is positive 16. So if I just take the opposite of both things, I get r is equal to positive 16. Okay? And that's how we use our model. All right. Now modeling does work forever, I suppose, if you want to keep drawing thousands and thousands of these things, but eventually you probably want to do a little bit less work. I know I don't want to draw 55 of those ones tiles. Okay? So what I'm going to do is I'm going to solve using opposite operations. So this first equation that I have here says -5 times the variable t is equal to -55. It's -5 times that variable t because the -5 is attached to the variable. It is its coefficient. Remember, a coefficient means a number that's multiplying a variable. So if I have -5 times t, the way I get rid of that -5 is I'm going to also divide by -5. If I multiply by -5 and then divide by -5, I'm going to get whatever number I started with back. So pick your favorite number. Mine's 8. So if I take 8 and I multiply by -5, I get -40. If I take -40 and divide by -5, I get back to positive 8. So I get my favorite number back. So if I multiply by something and then divide by that exact same number, I'm starting with the original thing I had. So since t is being multiplied by -5, then divided by -5, those guys are going to cancel one another out, and we're going to be left with just the t. Okay? Now, because this is an equation, I have to treat both sides the same because there's this equal sign in between, and it means that I must treat both sides equally because they have to have the same value. So if I'm going to divide the left-hand side by -5, I must also divide the right-hand side by -5. On the left, I'm left with only t, okay, because -5 divided by -5 gives me 1, right? So I get 1 over 1. -55 divided by -5, negative divided by negative is positive, and 55 divided by 5 is 11. Okay, now I've said in here I want to solve using opposite operations and verify. So what verifying is that's our way of checking our answer. So when I go to check my answer, I'm going to do a left side, right side chart, and it stands for LS as the left-hand side of the equal sign. if I look back to my original equation, on the left-hand side, I had -5 times t. So I'm going to work with just that. Now, I have a statement right here saying that t, instead of it being that letter t, should be positive 11. So I'm going to substitute that value, positive 11, back into my expression. Remember, when we substitute back into an expression, we use a set of brackets to keep things separate. Okay? So now I've got -5 next to a set of brackets, which means I should be multiplying. So it's -5 times positive 11. Negative times positive is negative, and 5 times 11 is 55. On the right-hand side of the original equation, I started off with -55. So both things are equal to one another. And we've solved it. Okay? So the verifying is your way of checking to make sure that the answer that you got is correct. Okay? The second equation here, so we've got r over 6 is equal to -4. Now when we write it like that as a fraction, r over 6, that line in a fraction means we are dividing. So I'm taking r and then dividing it by 6, and I need to undo that division by 6. So dividing by 6, the opposite operation of that is to multiply by 6. Now, some of you are going to be tempted to write an x for times, and I don't want you to do that because quite often your variable will be an x itself. Okay? So instead of multiplying and using the x, I'm just going to put it into brackets like this. And I'm going to treat both sides the same. Okay? So now if I take r and I divide it by 6, and then I take that answer and multiply it by 6, I get r back because the 6's cancel one another out. On the other side, -4 times positive 6 gives me -24. So now I have a statement saying the value for r should be -24. And I'm going to double check to make sure that that's actually right. So my left side of the equation started as r over 6, and I'm saying that r should be -24. So I'm going to substitute that in a set of brackets. So instead of r, I write -24, and -24 divided by a positive 6 is equal to -4. The right-hand side of the equation started off as -4. And we have the same thing on the left as we do on the right. Now again, I know that you guys can see these in your head. It will not always be that simple. So I do want you to practice these operations while it's easy so that when we see harder things next year in grade 9, you're already used to doing the correct steps, and all that you're going to have to deal with is the harder numbers. All right, sorry my first video failed miserably. Hopefully this one is a little bit easier to watch. Thanks, bye.